Hi, I am JD and this is Disrupting Disruption. When talking about blockchain, I get the same question every time. What is blockchain if we take out cryptocurrency? And I like to answer this based on the example of the automotive industry and 3 use cases. The first use case is the supply chain of the automotive industry, which is rather complicated. You don't see it at first, but as soon as you start digging into the details, you will start understanding the complications of that supply chain. Let's take a car and let's assume that you are now configuring a new car, so that it's just you and the brand that you have chosen. But it's not that simple, because it starts already with the fact that depending on the brand and the label, you can have up to 5,000 combinations of options that you can select. That car manufacturer will not produce that car in one factory. No, they have factories across the globe. They do that for different reasons. They do that to be closer to the consumer market. They do that to have less logistical cost. They do that to benefit from incentives, for example by being a local brand, although they are a foreign company. Many reasons to have plants around the globe. So that one car can be produced anywhere and most likely close to you. That already adds to the variations. But those car manufacturers are not making all those cars and all those parts themselves. No, they purchase parts. And this is something that most people don't realize. Your mid-class car is made out of 30 to 40,000 components if we count all the screws and nuts and all the parts that go into a car. 30 to 40,000 components, and these components themselves are again coming from different suppliers. Most car manufacturers choose to have different suppliers for the same part. They do that for commercial benefits, to have a strong price negotiation position, but also to avoid being dependent on one simple supplier. Now it gets really interesting. Those suppliers do the same thing as the manufacturers of the car. They have manufacturing positions around the globe because they also want to benefit from lower transportation cost, incentives, being close to the market, being close to where the manufacturers are, etc. Complicated enough? Well, that's just the beginning. Those different production facilities have different machines and different types of equipment, so most manufacturers are capable of producing parts and components on a set of machines, and it doesn't automatically mean that if a part was produced on one machine, it will be produced on that same machine the next time. That's the kind of flexibility which most manufacturers are working on at the moment, so it can be produced anywhere. If we just look at that, and then we look at the fact that we need logistic partners to move the parts between the production locations all the way up to the point that it ends up in the assembly line where your car, which you have just configured out of those up to 5,000 options, is going to be assembled. So with this one contract in which you order the car you just configured out of 5,000 up to 5,000 options, and that car which is manufactured from 30 to 40,000 parts and components, that takes up to 1,500 contracts with up to 200 different suppliers. It includes some 250 parties, which includes the labor force, which includes the logistics companies to move the parts around up until the point that they are at the assembly line where your car is finally assembled. If we take that all together, there will be up to 20 trillion different combinations to produce that one single car, because we also have to look at the different locations where the parts can be produced, and we have to look at the different machines within those locations where the parts are going to be produced. All this together makes the automotive supply chain one of the most complicated supply chains in the world, because there are so many options and there are so many parts involved. When we bring that all together and we look at the daily reality, we will see that, for example, recalls are a problem when there is a quality issue. But what we have learned from a couple of the recent quality issues is that not all cars should have been recalled. There was the famous example with the malfunctioning airbag, and it turned out that in one batch produced by one particular machine, this malfunction was caused. But the data required to identify that was not available, and especially not available in a timely manner. So the car manufacturer decided to recall all the cars in which this particular type of airbag has been mounted. Later analysis showed that more than 68% of the recalled cars shouldn't have been recalled at all, because the airbags came from a different manufacturing location. And out of the remaining part, more than 90% did not have that particular issue, because it was only one batch from one machine. So a lot of recalls, a lot of uncomfort, a lot of issues, a lot of problems. Consumers who were uncertain for a while, consumers who have to bring back their car and get it retrofitted and are not sure if it's now fixed or not. Those are all the consequences of quality issues. Now try to imagine that we would have put all those fingerprints from the machines, from the locations, from the factories on a distributed ledger. So all data, what was produced where and when was it produced, from which batch, from which supplier, would have been available, and the car manufacturer would have been able to analyze that information from a blockchain platform and just pick the cars which actually have the technical problem. That would have saved a lot of money. And we can use that in many other cases. We can use that to identify which cars need an update to be environmental friendly again. We could use the same distributed ledger for demand and supply. We could shorten the time between the planning and the actual production. All things we could do if all information would be available on a distributed ledger, on a blockchain. That is just looking at the production of a car. As soon as that car goes to its first owner, the second life cycle of the car starts. You will need insurance, depending on the country you're living in. You will need to pay taxes. You need to have services. All kinds of contracts exist again. It is really interesting to see that the value of a car is determined by a couple of simple facts. What is the actual mileage? Did the car have proper service? Are the proper parts used for that service? Was the car involved in accidents? Has it been properly repaired? This might not be interesting for the first owner, but it's definitely interesting for the second owner. And if we look at the average lifetime of a car will have in average 10 owners before it ends up on some scrapyard. So the second, the third, the fourth, maybe even the fifth owner would really like to understand, is that car having the actual mileage it is showing now? Experts estimate that 23% of the used cars have fraud in the mileage. Just one thing. But also the manufacturers themselves and their service partners will be very interested in knowing, are there original parts used on this car which is still under warranty? Is that the actual mileage which is still under warranty? Have there been any kinds of repairs which is not done by a qualified service partner? Interesting information. We could all combine that on a distributed ledger and benefit from the fact that once the data is on the distributed ledger, it's difficult or almost impossible to manipulate that. Would be great. Stop. Before you go shopping for your blockchain-enabled manufactured car. Let's have a critical and realistic look. One of the problems in the industry is that the partners are not really collaborating and are not having real standards when it comes to exchanging data. Reality is every manufacturer has their own standard and basically enforce that on all their suppliers. Why would they now suddenly have data standards to exchange data on a blockchain if they're not having it before blockchain? The second thing we need to look at is the cost of transactions. The cost of transaction for a blockchain transaction are at the moment still significantly higher than a transaction on a conventional system, if we take out all the benefits we think that we will have from blockchain. Just the clear cost of a transaction. Who will carry that cost? You, the consumer, I don't think you want to pay an additional price on your car for just maintaining some blockchains in which all information will be distributed. There is the consideration of privacy. Do you want all your data on that blockchain so the manufacturer can check on what you did with the car after you bought it and own it? There's even some legislation involved which says, not now and not in a public format. There's a technical perspective. It will take a lot of effort before we are able to interface between the existing systems and that external blockchain-enabled distributed ledger. Who is going to pay for that? Who is going to make sure that that will happen? Who is going to monitor that? Who is going to maintain it? Even if we would set up a system like that, there's cost to bear, and who will pay that cost? The owner of the car. I promised you 3 use cases, and here's the third one, and I think that's the most realistic one for now. Cybersecurity for smart cars, connected cars, autonomous vehicles and things like that. Let us start by looking at what Stefan Hendricks had to say about that during the Entity cybersecurity talks.
Up till very recently, car manufacturers produced cars and then the car was sold and it left the ecosystem because it, disappeared into the field, so to say, right? So there was no longer a connectivity between the manufacturer and the car. That is completely changing now, of course. And with self-driving cars, I think you'll see a situation where the cybersecurity of the self-driving car becomes a very important sales element as well.
So what we will see is that smart cars and autonomous vehicles will get back into the ecosystems of the factory. That's one thing where we have to protect the manufacturer against and their service partners. The second thing is that we have to make sure that such cars always have the latest, greatest patches and firmwares and information, of course, from a cybersecurity perspective. This is something where blockchain can really make a difference. A thrilling startup in that field is Esfin, co-founded by Mirko Ros. What Esfin is doing is basically creating a platform by which manufacturers can ensure over-the-air updates and patching of firmware of any kind of device. For the moment it's not planned to do that for the automotive industry, but I hope it will be somewhere in the future. It's important to understand one very simple fact. If the firmware has a vulnerability, blockchain won't help you protect against that. Blockchain will enforce that it will be distributed. But as long as the manufacturers make sure that those vulnerabilities are patched again, a platform like Esfin, based on distributed ledger technology, can make sure that it's enforced that it's distributed. That, I think, is a very good use case for the automotive industry, and I believe that we are much closer to that than any of the other use cases. What I would really like you to remember is the following. Just because we put the label blockchain on it, things are not going to happen automatically. Partners who do not collaborate at the moment will not collaborate in the future because it's now labeled blockchain. Transparency, which is not available now because entities and companies are not sharing information, will not start sharing that information just because it's blockchain. Let's focus on blockchain reality. It can be a very interesting platform. It has certain benefits when it comes to encryption and its distributed ledger technology. It also has certain downsides. The cost, electricity consumption, resources, required sizes of networks just to be resilient against hacking. Those are big costs. So we have to make sure that we use blockchain where we can actually benefit from it. Another cold reality is that the majority of the things we could do with blockchain platforms, we can also do with conventional technology at a lower cost. The main problem in transparency and sharing information is on the one hand lack of collaboration and on the other hand legislative uncertainties. This was Disrupting Disruption. Thank you for watching.